Hi, and welcome to this tutorial video. My name is Ogudimu Olumide Olalikon. In this video, we shall be talking about circuit theorem. Alright, circuit theorem is basically finding the angles within a cycle. That's just it. It's all about you finding angles inside a cycle. Alright, let's say you have a cycle like this, for instance, and you have something like this. So it's just all about you finding the angle within a cycle. That's circuit theory. You understand it now. Alright, so let's talk about some terms or some things we need to know about cycles. Alright, now the first thing we're going to be talking about is a chord. You need to be able to identify every part of a cycle. So let's talk about a chord now. A chord of a cycle is a line segment joining any two points on its circumference. Let me come again. A chord of a cycle is a line segment joining any 2 points on its circumference. Alright, let's say you have a cycle like this now. You understand it now. A chord is, this part of the cycle is called the circumference. So any line that is joining one part of the circumference to another, like it's joining the circumference together from one point to another, that's what without passing through the center of the cycle is called what? Is called a chord. For example, now I can have another chord here now. You understand? This is also a chord. In as much this line is not passing through the center of the cycle, it is called what? It is called what? A chord. So for example, if you have a cycle like this now, this line that connects this point to the other point is called what? A chord. You understand it now. So a chord of a cycle is a line segment joining any 2 points on its circumference. You understand? The entire body of this cycle, when you trace it around, is called what? The circumference. That's the total distance around the cycle. So all this part is called the circumference. So a line that connects one circumference to the other circumference without passing through the center of the cycle is called a what? A chord. You understand it now. So let us talk about diameter. What do we mean by diameter? Let us talk about diameter so we can talk about other stuff. So for example, now if you have a cycle like this, a diameter is a chord which passes through the center of a cycle. Any line any chord, for the fact that it touches or it connects a point to another, it is called a chord. But for the fact that it passes through the center now, it is called a diameter. So a diameter is a chord which passes through the center of the cycle. You understand it now. It divides the cycle into equal halves. That's what they call what? A diameter. You understand it now. So a chord which is not a diameter divides the circumference into two arcs of different sizes. A major and a minor what? Arc. Let us talk about it properly now. Let's talk about it properly. Alright, let's say we have a cycle here now. We have a cycle. Sorry. Let's say we have a cycle here. You understand it now. And we have a chord here. Let's say the chord is just something here like this. Alright, now as you can see now, this chord is not a diameter because it doesn't pass through the center of the cycle. You understand? It doesn't come like this. It's located here, somewhere around here. You understand it now? It's not passing through the center of the cycle. So it's a chord. You understand what I'm saying now? So now whenever a chord which is not a diameter divide the cycle, it divides that cycle into what? Into two major arcs, which we call what? The major and the minor arcs. For example, now when you look at it now, when you say major, that is the one that has the biggest part. Talking about something like this now, this is the arc of the cycle. You understand what I'm saying now? Sorry. This is what? The arc of the cycle. So this is what they call the major arc, and this other one is called what? The minor, the smaller one, right? The minor arc. So these are those things we need to know. All right. So when a chord which is not a diameter divide a cycle, it's divided into what, into two major arcs. Two main arcs, which is what, the major arc and the what, and the minor arc. Major is one, the bigger one, right, and the smaller one, right. All right. Also, again, let us talk about what we mean by segment. For example, let's say we have a cycle like this. Let's say we have another cycle. Oh wow, this is a very big cycle, very big one. I don't want this. Let's say we have a cycle, right? So now also the cycle is being divided by a chord which is not a diameter. Let's say we place it here now. You understand it now. All right, I want to shade what is there now. I want to shade something. All right, I want to shade something. Just give me this. You understand? Let me shade this part. Let me shade this part. I just want to shade everything that is here now. You understand it now? Let's assume that I shaded everything that is here. You understand? Let's see. I want to shade everything that is here now. All right. So this part shaded is called what? A segment. Right. It is called what? A segment. So I call this what? A segment, which is called what? A major segment. Segment is just like a kind of a portion of the cycle. When you have your orange now, like if you open the orange, you see it has a lot of segment or whatever. So this was a segment. You understand what I'm saying now? And these are other words. Let me just paint this side again. This is the word. This is the other word, segment. That means the one inside is called a segment. But in this part now, one is bigger than one. So the bigger one is called a major segment, and the smaller one is called what? The minor segment. Minor segment. So that's just what we need to know. All right, now let us quickly talk about something again. Let's talk about something again. You will discover that if you have something like this, let's say we have another cycle again. Oh, let me use a better one this time around. Let's say we have another cycle like this. You understand what I'm saying now? And we have a chord again which divides this thing like this. Now let us say we now have a bigger angle here, so you don't mind, it might not be, let's just take it like that. Okay, fine. Sorry. Okay, let's say we have a bigger angle here now. I'm going to call this, okay, let's do it first. Let's say we have a bigger angle here, and I'm going to give this one a kind of dot. So it's meant to be a straight. Okay, let me just do something like this, right? This is the chord, right? All right, let's say we now have another angle here again, which is something like this and something like this, and we also have another angle here again, something like this and something like this. You discover that all this angle now, they are subtended at the circumference by the chord or by the minor arc. This arc is one that sustains, that pushes this one up, like that I mean, is the source of this angle that are here now. You understand now? So you see this angle that we have, let's say this is angle A, this is P, and this is AB. Let's say let's use this on R, PQ and R. You understand? So these angles that are here now, they are angles subtended at the circumference by the chord, and they are all angles in the same major segment. All these angles now, they are angles in the same major You can see now when you have something like this now, this big part from here upward like this is the major segment. So all these angles that are here now, they are all angles in the same segment, in the same major segment. All right. So what about if you have something like this now? Let's say we have another cycle. Let's say we have another cycle like this. We have another cycle. All right, and we have some lines again. Let's say this is the chord as usual. Oh, sorry. Let's say this is a chord. Let's say this is a chord, and sorry, it might not be. Let's just leave it like that. Let's say it's a chord now. Like we have something like this, and we also have something like this, and we have something like this and like this. So like let's name this A and B, and let's name these X and Y. Please don't mind my diagram, it might not be as perfect as possible or as I think. All right, so now these angles this angle ABXY, they are angles that are formed in the what, in the minor segment. They are in the minor segment. I told you what a segment is. This part is the major segment, and this part is the what, is a minor segment, the smaller one. So there are angles that are formed. These particular angles here that we have here now, they are formed in the minor segment. All right, so we shall be talking about so many stuff in the next video, but before I end this video, let me quickly do one example, or let's talk about one theorem about the chords. All right now, and the theorem states that what, a straight line drawn from the center of a cycle to bisect a chord which is not a diameter is at right angle to the what, to the chord. All right, let's say we have something like this now, and according to the theorem, a straight line drawn from the center of a cycle to bisect a chord which is not a diameter is at right angle to the chord. A straight line drawn from the center of a cycle. Okay, let's say we have a chord here, or probably let me use a better one. Let me use a better cycle. All right, so we can get it better now. And let me use a better cycle. And before that, let me quickly write what I want to say now. A straight line drawn from the center of a cycle to bisect a chord which is not a diameter rather, is at right angle to the chord. All right, let us quickly look at this now. Let me just place it somewhere. Let me place it somewhere here. All right, let me place it somewhere here now. All right, so a straight line drawn from the center of a cycle to bisect a chord which is not a diameter is at right angles to the chord. Okay, now let's say we have a chord now, so that we can understand this better. Let's say we have a chord, and let's say this is a chord. All right, now according to this theorem now, it says a straight line drawn from the center. All right, let us pick this as the center of our cycle, for instance. So a straight line drawn from the center of a cycle to bisect, that is to divide this chord into two. Let's follow this theorem now. Let's say this is a straight line that is drawn from the center of the cycle to bisect this chord, which is not a diameter. You know, this chord is not a diameter, right? To bisect this chord is at right angle to the chord. So this straight line that is drawn to bisect this chord is at right, as you can see it, is at right angle to the chord. Let me just draw it very well. It's at right angle to the chord. So that's just the explanation to this theorem. A straight line drawn from the center of a circle to bisect, to cut the, to cut a chord into two, right? To divide into two, to bisect a chord, which is not a diameter, is at right angle to the chord. This is where we are going to be starting from. Let's say this is our A and a B, and right? Let's call this what the midpoint. We call it what M. You understand? So, and by the time you do this now, you discover it's going to form an angle, right? Something like this, and so we are going to be talking about it in our next videos, and okay, we are going to be talking about some examples. Okay, fine, let me give one example on this before we end this video. All right, so let's say we have a question like this. Let's talk about this question. Let me quickly write this question. All right, let me write this question. Calculate the distance of the midpoint. It's a very simple one. Of the midpoint of the chord. From the center of the cycle. All right, let's quickly get this question. Let's get this question well. Sorry, let me just reduce this a bit. All right, a chord of a cycle is 12 centimeters long. The radius of the cycle is 10. Calculate the distance of the midpoint of the chord from the center of the cycle. All right, it's just our ability to interpret this question. Let me first draw the cycle so we can get it better. Let me make a smaller one so we can get it better. All right, the question says a chord of a cycle is 12 centimeters long. All right, by the time we have to draw this chord now, let's say we want to draw this chord now, it's going to be something like this, right? So the total length of this chord, it says what? 12 centimeter. It's 12 centimeter long, right? So the radius of the cycle is 10. Definitely a radius is going to be from the center, right? Let's say this is the center of the cycle, for instance, please. Let's just take it like that. They say the radius is what? Is 10. All right. So sorry, the radius of the cycle, they say is what? Is 10. Let's take it like this. The radius of the cycle is what? Is 10. It's going to be this. That the one I drew initially is not the radius because it doesn't touch the circumference. Sorry. So this is the radius of the cycle. A line that is drawn from the center to meet one part of the circumference is called what? A radius. You understand? So let's say the radius is what? Is 10. The answer is you calculate the distance of the midpoint of the chord from the center of the cycle. Calculate the distance of the midpoint. This is the midpoint now, from here to here. So let me draw it very well. From here to here, that's what they want us to calculate. The distance of this midpoint of the chord from the center of the cycle. We want to know the distance of this place, the distance of this midpoint from here, from the center of the cycle. So what are we going to do now? Let's talk about the question again. A chord of a cycle is 12 centimeters long. The radius of the cycle is 10 centimeters, which is this 10 centimeters that we have here, which is the radius. Calculate the distance of the midpoint of the chord from the center of the cycle. I just want to know the distance of this, the midpoint now, the line that bisects the chord. You understand now? It's you have a midpoint here now. So they want to know the distance of this midpoint They want to know the distance from the center of the cycle. Like what's the distance of this line from the center of the cycle. Alright, it's very simple. This is what you're going to do now. You have been given one part of it, and this is 12. And we are meant to get this part of this side of the cycle, I mean of the line, the distance. This is what you're going to do now. You just let's bring it out again. Let's say we have something like, let's say this is the question now, and we are meant to look for something like this, and this is what they gave us. They gave us this one as 10. Let me draw it very well, please. So right, so this is 10, and they said from year to year, sorry, from year to year, they said is what is 12. But now I can decide to split it into two and say this is what 6 and 6. You understand? It's still the same thing as the length of the word of the chord. So if this is 6 and 6 now, it means I can easily get this part. Let me call this guy my hex. You understand what I'm saying now? This is what I want to look for. The total length is 12, and I split it into what? Into 6 and 6, which is still the same thing as 12 as the total length of the chord. Alright, now in this case now we are going to use what they call Pythagoras theorem. You understand it now? Alright, now to get this x now, you say what? Hypotenuse square, according to Pythagoras theorem, hypotenuse square is equals to what? Opposite square plus adjacent square. Opposite square plus adjacent square, right? So the hypotenuse here is what? Is the 10, right? So we say 10 square is equals to what? Let's say x square plus what? One of the side, which is what? 6 square. So in that case now you have what? 100. 10 square is 10 times 10, which is 100, which is equals to what? X square plus 36. Alright? So in that case now what are you going to do now? You collect your like 10, right? You send 36 to the other side, right? So 100 minus 36 will give me what? X squared. So what is 100 minus 36? 100 minus 36 is what? Is going to give us what? 64 is equals to x squared. Then if 64 is x squared, your x will be equals to what? The root of what? 64. So what is the square root of 64? Sorry. Your x will be equals to the square root of 64. This is a very tiny place. Root of 64. So your x is going to be the square root of 64. Let me just write here so you can see. X will be equals to what? The square root of 64. And what's going to be your x? X will now be equals to what? The square root of 64 is what? Is 8. So your x is 8 centimeter. That is how to answer a question like this. Let me quickly come again now. The question says a chord of a cycle is 12 centimeter long. The radius of the cycle is 10 centimeter. Calculate the distance of the midpoint of the chord from the center of the cycle. Alright. A chord is 12 centimeter long. This is the chord. From year to year is the chord. Alright. It's 12 centimeter long. So what again do we have there? They gave us the distance of this chord, which is 12 centimeter long. The radius of the cycle, which is this part, they say it's 10 centimeter. Alright. Calculate the distance of the midpoint of the chord from the center of the cycle. They want us to calculate from year to year the distance of the midpoint from the center of the cycle. Now, since they gave us this part as 10, the radius, and they gave us the total length of the chord as 12, I can see that I'm only trying to look for the third part, and I can easily split this one because they are equal. It's a midpoint. It definitely divide this chord into two. So the total length is 12, so I can say it is what? 6 and 6. Alright, and they gave me this part as 10. They want me to look for this height, this x that is here now. Then I'm going to use Pythagoras theorem, which said that what? Hypotenuse square is equals to opposite square plus what? Adjacent square. The hypotenuse is this 10 now. So 10 square will give us what? This part, x square, this height here, x square plus what? The 6 that is down here, 6 square. So 10 square is 10 times 10, which is 100, which is equals to x square plus what? Plus 36. This is 36. I wrote 36 here. 36. So 100 is minus 36, because this 36 will come to the other side and the sign is going to change to minus. Will give us x squared. So 100 minus 36 will now give us what? 64. So x squared will now be equals to 64, right? That's what we have here. X squared will be equals to 64. Then x will be equals to what? The root of 64, which is what? 8 centimeter. So that's just that about that. See you in the next video. Bye bye. If you have any question, please don't forget to comment.